Alright, let's talk about 5.3, the other trigonometric functions. Given theta some real number, any real number's fine, and x comma y, the point where the terminal side of theta intercepts the unit circle, we have that. And then we have these four functions here, each one of them defined in terms of sine and cosine. So we have these four functions here, and you'll notice that each one of them are defined in terms of sine and cosine. So if you know sine and cosine, then you know these other things, and they're all here. First, you have the tangent of theta. So the tangent of theta, that's defined to be y over x, and we'll get to this in 5.4. But this is just sine over cosine, and this is assuming that x isn't 0. That is, cosine, the thing you're dividing by, isn't 0. Next, you have the cotangent function. It's the cotangent function. And it is exactly the opposite of tangent. It's actually 1 over tangent. It's x over y, or cosine over sine, as long as y isn't 0. That is, sine isn't 0. So cotangent is just the cosine over the sine, or the x-coordinate over the y-coordinate. You all already know that the tangent is just the y-coordinate over the x-coordinate. And then there's two others. There's secant and cosecant. So right here, we'll look at this. There's secant, and then there's cosecant. One word. So there's tangent, cotangent, secant, and cosecant. Secant is 1 over x, or 1 over cosine x, where x isn't 0. That is, you're not dividing by 0. That is, cosine isn't 0. And cosecant is 1 over y, or 1 over sine, where y isn't 0. In terms of using the unit circle to figure out what these are, these down here are more useful. In terms of actually knowing the definitions of these things, these guys here are far more useful. But they're all true. If I ask you what tangent is, you can tell me sine over cosine. That's probably what I'm looking for. That's called a quotient identity, and we'll get to those later. Cotangent is cosine over sine, also a quotient identity. And then you've got your reciprocal identities. Secant theta equals 1 over cosine theta, and cosecant theta equals 1 over sine theta. Also, this Greek letter theta, it continues to mean angle, and it almost always means in radians. So if you see theta, think angles. Just think angles for the rest of your time in mathematics. But those are the four trigonometric functions. So with that being said, let's move on and let's look at this example down here. So let's look at this here. It says, given that theta is 2 pi over 3, it says find the values of the 6 trigonometric functions. So let's think about this this way. So first, let's go get ourselves a circle here, and let's put it over here on the right. So let's get this circle up, about like that. And then let's try to find the center-ish, best I can. That'll do. And then let's go back to my pen, and let's go get an angle of 2 pi over 3. Now, you all should know that pi over 2 is straight up, and 2 pi over 3 is roundabout here, I'd say. So that right there is 90 degrees. And then if I come over another 30 degrees from there, about there, that's close enough. So this point right here is 2 pi over 3. Now it's 2 pi over 3. This is the terminal side. Remember, the initial side is always just the positive x-axis. So it'll look kind of like this. There we go. And what we're talking about then is this, this red angle. This red angle here is 2 pi over 3 radians, or 4 pi over 6 jumps, or 120 degrees. That's what we're talking about. And of course, the coordinates up here, you all have in your head by now, are negative 1/2, because we had to go negative to get over here. So negative 1/2 root 3 over 2. Positive root 3 over 2. And remember, anytime you think about this, that that necessarily tells us our x and our y. So I hope that you wrote down everything that we'd already went over. The definitions of tangent, cotangent, secant, and cosecant. If you haven't, rewind the video and write those down so that you have them, because I won't scroll back up to look at them. You can just have them in front of you. But look at this. We know that Cosine, for example, cosine of theta, that's just the x-coordinate. The x-coordinate is just 1/2. So cosine of theta is just the x-coordinate, and it's just negative 1/2. Remember, we're trying to find all 6 of them. The next one is sine. It's the next easy one to find. Sine theta is always just the y. In this case, the y is just root 3 over 2. Okay? We can find tangent, which we've done before. Tangent of theta is y over x. So it is exactly root 3 over 2 over negative 1/2. And then to do this math, you just do root 3 over 2 times, and then flip negative 1 over 2, so it'll be 2 over negative 1. And then the 2's will cancel, and then this is square root of 3 over negative 1, which is just negative square root of 3. So the tangent of theta here is negative square root of 3, and it's negative because we're in quadrant 2. And so those are easy, and these we've seen before. Tangent hasn't been explained before, but you've done some exercises on it. But let's look at the other 3. So tangent's the first of the other 4 that we talk about here. Let's do the next one, which is pretty easy. It's cotangent. So it's the cofunction of tangent, and we'll get to what those are in the next section. It's just x over y. So it's instead negative 1/2 over root 3 over 2. And this time when you do the math and you flip it, you get negative 1 over 2 times 2 over root 3. And the 2 still cancel, but now you've got negative 1 over root 3, which if you multiply top and bottom by root 3 over root 3, that is, you multiply the top by root 3 and the bottom by root 3, you'll get that this comes out to be negative root 3 over 3. So then the cotangent of theta, if theta was 2 pi over 3, is negative root 3 over 3. There's just 2 more of these things to go. Let's look at them. They're pretty easy. There's secant of theta. So secant of theta, you would want secant of theta, since it starts with an s, to be 1 over sine, because they both start with an s. Yeah, but that's not how it works. So get that right out of your head. Secant and cosine go together, because math's dumb sometimes. So secant is 1 over cosine, or 1 over x. So we just do 1 over x. And let me put it in a nice red here. 1 over x. So it'll be 1 over, and then x was negative 1/2. I'm just getting it from straight up here, straight off the unit circle. So 1 over negative 1/2 is negative 2. So the secant of theta in this case is negative 2. Let me go back to a blue here so that it doesn't blend in. The last one of these that we're doing will be cosecant. CSC of theta. That's just 1 over y. And remember y was just here, root 3 over 2. So this will be 1 over root 3 over 2. 1 over root 3 over 2, like that. So this is just 1 times 2 over root 3. 1 times anything, the 1 just dies in a fire, but the next thing is you need to multiply this top and bottom by root 3 in order to get anywhere, so we can go ahead and do that. Multiply by root 3 over root 3. That's just 1, so 2 times root 3 is 2 root 3. And by definition, anything times itself is that thing squared. Root 3 times root 3 is root 3 squared. If you square a square root, you just get what's underneath. So 2 root 3 over 3. That's what the cosecant of theta is for 2 pi over 3. And that's all 6 of the values. You'll notice them right here. There's cosine, that's 1, sine is 2, tangent's 3, cotangent's 4, secant is 5, cosecant is 6. But if you can remember these basic definitions, it's as simple as looking on the unit circle and figuring out what it is. And by the end of this class, by the end of this section, in fact, we will have found all 6 of these for every single one of the major unit circle points. So get ready for that. But that is how to do one of these. Let's move on and do another. So here's the next 2. The first one says, given theta equals pi, find the values of a 6 trigonometric functions. And I want to go over this. So let's again pull ourselves up a circle. And let's look at this. This one doesn't have to be quite as big because it's just pi. And then let's get ourselves this back. And let's go in the middle here. And then let's get our reference angle here. And then let's get our theta equals pi. Well, that's just 180 degrees. So it should be straight. And that's as straight as I can get it. So this is your angle here. This is theta equals pi. And of course, you're going to want the unit circle points here, which is you went back -1 and up or down 0. So that's all the information that you need from the unit circle. Of course, you don't have to draw the unit circle to do this. You don't have to at all because it's already drawn. I'm drawing it for the sake of your notes, but this will be very quick. So let's find these. Let's find cosine of theta. Remember, cosine of theta is just the x-coordinate, so it's just 1, always. The sine of theta is the y-coordinate, so it's just 0. The tangent of theta is just 0. What's y over x, so it's just 0 over -1. 0 over -1. Now, you may notice that in the last example I wrote, cosine of theta equals x equals this. Sine of theta equals y equals this. Tangent of theta equals y over x equals this. I'm not this time actually writing in the letters. If you would like to, in your notes, write in the letters, of course, go ahead and do that. Back up. Do that if you haven't already. By all means, do the extra work. But this is what I would accept if I were to see it on a test. You don't have to write the x and y part. It just helps to keep track of things. Of course, 0 divided by anything other than 0 is just 0. So tangent of theta is 0. Now we get into the weird ones, and this is sort of the big point that I wanted to make. We can look at cotangent. So cotangent of theta is, well, it's just this but flipped. It's -1 over 0, so it is undefined. You can't divide by 0, so it's undefined. Do not tell me this. Do not tell me this. This equal sign right here doesn't mean anything. There is no definition. If you say that something equals something else, they have to both be defined. But if this is what you get out in your calculations, be like, oh, okay, well, then it must be undefined. Similarly, with cosecant, which is... Similarly, with cosecant of theta, which, if you look back in your notes again, is just 1 over sine, or 1 over y, you'll get, in this case, 1, that's from the definition, over 0, because that's what this is. That's also undefined. It's also undefined. And the best way to say this would be just say cosecant of theta is undefined. That'd be the better way to say that. And then secant is totally going to exist. Secant of theta is just going to be 1 over whatever the cosine is. So 1 over -1. So it's just -1. So in this case, secant and cosine are the exact same thing. Now we understand, or will soon understand, where the cosine and sine functions come from. And tangent has some geometric meaning as well. But the cotangent, the cosecant, and the secant all have meanings as well. And there's a really cool image that I'll show you in class at some point. But all of these things originally were useful in navigational purposes, especially navigation of ships and whatnot. Back when we didn't have GPS, this is how you found your way around the globe, and indeed it's actually how GPS systems work, just using this sort of thing. So if you're wondering where any of this is useful at, well, it's the reason that you can get to someone's house that you've never been to without following ridiculous southern directions. You all know what I'm talking about. Let's move on and look at the next example, though. Last one here says, given theta equals -2 pi over 3, find the values of the 6 trigonometric functions. So you'll see that this is exactly like the previous one, the first one that we did, except I threw in a negative sign. So how much does that really change things, you might ask yourself? And the answer is a lot, actually. Let me show you. So here is the circle that I want to show you. Let's just put it right there. And let me go ahead and grab this, and let's make our center about here, and then our initial angle, which is always the positive x-axis, And then we ask ourselves, what does this negative mean? Well, a positive angle goes around this way, that is counterclockwise, and a negative angle goes around this way. So what we need to do is swing around 2 pi over 3, that is 120 degrees, but instead of swinging around this way to right here, we're going to start right here and we're going to swing around this way to right here. That is, this angle right here is theta equals negative 2 pi over 3. Now, you may notice something about this angle right here is that it is coterminal with this angle here, which I'll call theta prime, which of course we know to be 4 pi over 3. Positive 4 pi over 3. They're the same angle. And indeed, you'll notice always, if you take the absolute value of your negative angle and add it to its coterminal angle, you should get 2 pi. That is, this distance here, this distance, this red distance here, plus the rest of this blue distance, except going the same way as the original red distance, should be 2 pi. That should make sense. And indeed it does. So 4 pi over 3 and negative 2 pi over 3, they're coterminal angles, which means they have the same point. So you might not know the point for negative 2 pi over 3, and you might be convinced just to go ahead and go put in 2 pi over 3 stuff, which is the negative 1/2 root 3 over 2 that we used to have, but instead we're going to use the negative 1/2 negative root 3 over 2 that we need. So negative 1/2 negative root 3 over 2, and if you don't know where you got this from, it's just straight off the unit circle. It's just one part of the unit circle. So all that we need are these coordinates, and then finding these 6 trigonometric functions are super easy, barely an inconvenience. And just for the sake of your notes, I'll do it this one last time, and then you won't expect to see me do this much more outside of the next section where it's useful. But remember, sine is just y, and y is just negative root 3 over 2. And you organize this however you want to. The cosine of theta is negative 1/2. This is just another way to do it. That is, negative 1/2 was just your x, so it's just negative 1/2. Okay. Now let's do the other pair here. Let's do tangent, which was y over x. So tangent of theta is y over x. So y was root 3 over 2 over 1/2. Root 3 over 2 over 1/2, except they're both negative. So we'll get out a positive number, but if you go back and you look up in your notes, you'll notice that it's this, with the exception of the negative signs, it's the exact same math. You're going to get root 3 out of this, except this time it's going to be positive because there's 2 negatives involved. Keep that in mind, and when you're doing all of these all the way around the unit circle, you can start noticing some patterns. There's a reason I picked this one in particular. In the same vein, when you do cotangent of theta, you're going to do the exact same thing. You're going to get negative 1/2 over root 3 over 2. And that math, just like in example 1, is going to work out the same way, except this time there's 2 negative signs involved. That is, there's this divided by this, so the answer is going to be a positive root 3 over 3. If you want to see the math and you want to write all the math out in your notes, that's fine. Go back and look at example 1. I'm just trying to show you the patterns that you can see. You can use prior work. Since we have to do all of these on the unit circle, and I'm just doing a few, I want to show you that there are ways to do it. So I am actually doing it for 4 pi over 3. At the same time, I'm doing it for negative 2 pi over 3 by using normal 2 pi over 3, that is this guy's measurements. That is, this guy up here would have been negative 1/2 positive root 3 over 2. Well, it's the same math except for the whole negative part. Anyway, so that's sine, cosine, tangent, cotangent, and then I just need secant and cosecant. So secant of theta in the same vein is just going to be 1 over negative 1/2, and 1 over negative 1/2 is, of course, just negative 2. And then cosecant of theta is going to be 1 over negative root 3 over 2, which we've done this math before, but I'll write it out for you again. It's 1 over negative root 3 over 2. And you've already done earlier on your paper 1 over positive root 3 over 2. And when you did 1 over positive root 3 over 2, what you got was 2 root 3 over 3. But this time there's a negative involved, so just put the negative in there and you're done. If you want to see the rest of the math, how I got all this, just go back up and look at example 1. That's it for this entire section, by the way. There's a lot of these things to be done. In fact, there's about 100 of these problems to be done. And you can look forward to a very nice worksheet on that. But the good news is that once you've done all 6 of these trigonometric functions for every single one of the angles on the unit circle on a single sheet of paper, you have them all on a single piece of paper, and you don't have to do this math again. So you do it once, get it out of the way, and then you're ready to go for the rest of Trig, for the rest of Cal 1, for the rest of Cal 2, and for the rest of your math career. So I hope you all got something out of this. I'll see you in the next one.